entering the virtual labs, you'll find an option called Digital Applications Lab. Get onto it. Then in the Digital Applications Lab, there will be an option called List of Experiments. So tap on it and you'll find the project named Water Level Control using Basic and NOT gates, which is the project now we are going to carry out. So the water level control using basic and NOT gates. Here we are going to construct a simulator by using the basic and NOT gates, which gives an alarm when the water level exceeds a given limit. So the aim of the experiment is to use the combination of and NOT gates in water level controller application. Here the user will able to find the output status of the water level for the given combination of inputs. This construction of basic and NOT gates will enable the user to analyze, construct, and simulate, and to verify any combinational logic circuit for a given problem statement using the generalized simulator. So let us dive on to the theory of this water level control, which we're gonna construct it by using the basic and NOT gates. So the introductory part is many industrial and domestic applications use the basic and NOT gates to either indicate or control operations such as turning on or off of alarms, indicators, digitally controlled tank valves, heaters, motors, machines very efficiently. So as these are the large scale multi-story buildings, these turning on or off of alarms, indicators, etc. cannot be done manually in a frequent manner. So it needs to be automated. So in such cases, they use this basic and NOT gate simulator to turn on or off these switches, alarms, indicators, heaters, motors, etc. So the application of this water level controller is, so let us consider the case of a water level controller system installed in a multi-storied apartment. Practically, you may design a circuit with multiple sensors that indicate the low and high levels of each tank. Though the design complexity increases with the additional number of sensors involved, the system performance turns out to be robust to handle a variety of water level combinations. So practically in the multi-storied apartments, they have a separate sensor for each tanks, which is very difficult to handle all these sensors simultaneously at one time. For simplicity, let us consider only two level sensors. Here we are not going to use many more sensors as it is very tedious one. We are going to consider only two level sensors A and B with digital outputs located in the lower tank and upper tank respectively. So here the concept we are going to apply is the motor should turn on only when the lower tank is full and the upper tank is empty, and for all other conditions the motor should be off. Here the concept is, so there will be two tanks, just we are gonna implement only two sensors, that is A and B sensors, not many more sensors, because in the, as I said earlier, the multi-story apartments use many sensors for each tank, which is very tedious one to handle all the sensors. So we are going to use only two sensors A and B. Here when the lower tank gets full or gets started to fill, automatically the motor will get turned on. For all the other conditions, the motor remains turned off. So when the lower tank gets full, the motor should be turned on. For all the other conditions, example, if the lower tank is only half mode or below the limited mode, or in the case if lower tank is empty, only the upper tank gets full, the motor should be turned off. So the only concept of this water level controller is that the sensor should indicate or should give alarm when the lower tank gets full and the motor should turn on. Unless the lower tank gets full, the sensor should remain off and the motor will also remain off. When the lower tank gets full, the sensor implemented in the lower tank, which is known as the AL, gives an alert and the motor automatically turns on, from which the water from the lower tank gets redirected to the upper tank. So after the upper tanks get full, the motor will goes off. That is how this water level controller works. So let us indulge into the concept of this by the truth table in a detailed manner. So this AL represents the sensor implemented in the lower tank, and the BH represents the sensor implemented in the upper tank, and the motor Y is the output. So let us see in what conditions the motor gets turned on and in what conditions the motor remains turned off. So when both the sensors in the lower tank and the upper tank remains off, the motor is also remains off. Then the lower tank remains empty and the upper tank alone gets full, the motor remains off. The lower tank gets full and the upper tank remains empty, the motor gets turned on because the sensor gives the indication that the lower tank gets full and the water from the lower tank should be redirected to the upper tank. So in that case, the motor gets turned on and the water from the lower tank gets transferred to the upper tank. So, and when both the lower tank and the upper tank gets full, the motor remains off. So after the truth table, the Boolean expression defining this water level control operation is given by equal to A into B bar. That is the output motor equal to the sensor implemented in the lower tank into the inverse of the sensor implemented in the upper tank. That is, we are using only the two basic gates, basic NOT gate and basic AND gate, and we'll get the output as this. So after the truth table, we are going to see the Boolean expression defining this water control operation, which is given by the output motor equal to the sensor implemented in the lower tank and the inverse of the sensor implemented in the upper tank. That is, M is equal to A dot B bar. So this water level controller is constructed by using the basic AND and NOT gates, which is earlier given in the heading of this topic. So this circuit is achieved by this basic and NOT gates. So let us get on into the procedure of this water level controller. That is, let us check on how this water level controller works. So set the conditions for the level sensors A and B as per the truth table. That is, when the lower tank AL remains 0 and when the upper tank BH is 1. And let us set the condition as when the lower tank AL gets full and the upper tank BH is empty. So let us set the conditions for the level sensors. Then let us observe the output. Verify the functional truth table for the system. So using simulator, build the water level control circuit and verify the result. In generalized simulator, replace the input sliders and the tank by digital switches. So let us get on into this. So let us consider two tanks. That is, tank A will be the lower tank, tank B will be the upper tank. These two tanks are constructed by the circuit which involves the NOT and the AND gates. So as I said, so let us set the conditions according to the truth table. So the motor should turn on only when this lower tank gets filled. Unless this lower tank gets full, the motor should remain turned off. So let us keep this in a high manner and this remains in a low level. The motor here, the output is the motor, it remains turned off. So let us increase to the greatest. So this is the upper tank and this is the lower tank. So it is of the, in case of truth table, let us say this as it remains as 0 and this will be 1. So the motor remains turned off. So let us make this lower tank into 1 and this upper tank into 0. So let us make this lower tank, the motor. So the motor turned on and the water from the lower tank A will be redirected to the upper tank B. So this is how this water level controller works. So let us check on another condition. So let us keep both the tanks A and B into 0 level. So the motor remains turned off. So whatever the conditions you keep, the motor remains turned off. But in except the one condition, when the tank A is about to fill, the motor gets automatically turned on and it redirects the water from the tank A to the tank B. And after the water gets filled in the tank B, the motor gets automatically off. So this is how the water level controller works, which is constructed by using the basic AND and NOT gates. Thank you.